Hello everyone, welcome back to the video for motor control. Okay, we continue. Now I insert the command for each program group. This override. And this for auto and manual request. Next, start or stop request. Create a new run. Insert SIO. With text, motor, direct, override. Next, SIO with text, motor, direct, automan. Next, XIC with text motor direct upper stack request. Then list to an OTE motor direct command status. After SIO with text motor direct automan, insert a new brand with XIO motor direct upper stop request. And XIC motor direct command status. Then also lead to OTE motor direct command status. After SIO with text motor direct override, insert a new brand with XIC motor direct automan. And XIC motor direct program. And XIC motor direct process interlock. Then also link to OTE motor direct command status. That's for command status. Now program for operator stack and stop request. Create a new run. Insert XIC motor direct upper stack request. Lead to an OTU motor direct upper stack request. At beginning, insert a branch with a XIC motor direct upper stop request. And lead to an OTU. Motor direct upper stop request. Next, for on and off stage, create a new run. Start with the XIO motor direct thermal overload. Next is XIC motor direct hand switch on. XIC motor direct command status. XIC motor direct running feedback. And lead to an OTE motor direct on stage. After the XIO motor direct thermal overload, insert a new branch with XIO motor direct command status. XIO motor direct running feedback. And lead to OTE motor direct off stage. Next, for output, create a new run with the XIC motor direct command status. Lead to an OTE motor direct output. Next, I will create the logic for phone alarm. When will the motor be full? We have 5 reasons. First reason is when the motor is requested to run from PLC, but after the full timer time, the motor on site not run. Second reason is when the motor is requested to run from PLC, but after the phone timer, the motor on site not feedback run or stop. It means on state and off state clear at the same time. Third reason, when the motor is requested to stop from PLC, but after the phone timer, the motor on site not stop. Fourth reason, when motor is requested to stop from PLC, but after the phone timer, the motor on site not feedback run or stop. It means on state and off state clear at the same time. Fifth reason, when the motor not receive any feedback, mean on state and off state clear at the same time. No need to wait for phone timer. Okay, we create a new run. I will use NEQ, not equal instruction. And compare the motor direct phone timer preset with 0. What does it mean? Some motors, we don't set the full time. Those motors are not important and we don't need to monitor the fall. So we compare and we just care any motors had the full time. Next, I use XIC motor direct command status. To determine the motor is requested to run. Next is one shot. I select the motor direct one shot number 3. That's the condition to see the command from PLC to control the motor to run. And next, we put the actual feedback from on-site motor with XIO and the text motor direct on state. Next, the phone timer. I use the timer on. And let the preset and accumulate time at 0. When logic used for specific motor, this timer will take the preset time from that motor. That's the first reason. Next, we add the new branch after NEQ instruction. Use XIC motor direct phone timer N. And XIO motor direct off state. Then come back to a Bob run before one shot. That's the second reason. Next, we add a new branch after NEQ instruction again. Use XIO motor direct command status. To determine the motor is request to stop. Next is one shot. I select the motor direct one shot number 4. That's the condition to see the command from PLC to control the motor to stop. And next, we put the actual feedback from on-site motor with XIO. And the text motor direct off state. And we connect this branch to the phone timer also. Sorry. That's the third reason. Next, we add a new branch after NEQ instruction again. Your XIC motor direct phone timer N. And XIO motor direct on state. Then come back to a pop run before one shot. That's for reason. I have a little bit mistake here. This is the after the one shot. Next, see the condition for phone alarm bit. After NEQ, we insert a new branch or create a new run and XIC with tag motor direct phone timer done. And lead to an OT with tag motor direct phone alarm. Next, we add a new branch after NEQ again. Your XIO motor direct off state. and XIO motor direct on stay. And XIO motor direct phone timer in. Then lead to OTA motor direct phone alarm. Sorry. That's the fifth reason. Next, I program for acknowledge the phone alarm. Create a new run. Insert the SIC motor direct phone alarm unlocked. Then lead to an OTU motor direct phone alarm. A new brand, an OTU motor direct phone alarm unlocked. And a reset motor direct phone timer. Next, for mode alarm. When we have the mode alarm, it's when the motor is in the manual control and a program command changes to a state which is different from the state currently commanded by the operator. This alarm is intended as a reminder that motor were left in the manual control. Create a new run. Insert the SIO motor direct automan. Exio motor rack override. And Exio motor rack pro command. One source motor rack, one source number 5. XIC motor rack command status. XIC motor rack project interlock. Then lead to an OTL motor direct mode alarm. After Exio motor direct override, insert new branch. Next is XIC motor rack command status. One short motor rack, one short number 7. Sorry, one mistake. This is the motor rack pro command. Yes. One source motor rack number 6. SIO motor rack command status. And come back to abort run but before XIC motor rack process control. After XIO motor rack override, insert new branch. Next is XIC motor rack command status. One source motor rack number 7. XIC motor rack pro command. Then lead to an OTU motor rack mode alarm. After SIO motor rack override, insert a new branch. Next is SIO motor rack command status. One source motor rack, one source number 8. SIO motor rack pro command. And come back to abort run and also lead to OTU motor mode alarm. Parallel with a port run here, insert new branch. Next is XIC motor pro command. One shot motor one shot number 9. XIC motor command status. And also lead to the OTU motor mode alarm. Parallel with a port run, insert new branch. Next is SIO motor row command. One shot motor number 10. SIO motor command status. And also lead to the OTU motor mode alarm. Create a new run. Insert the SIC motor automan. SIO motor command status. Then lead to an OTU motor mode alarm. Insert a new branch. Insert a SIO motor override. Insert an one source motor one source number 11. Then lead to OTU motor mode alarm. Okay, that's all for the logic of properties of motor direct. Now we come to program for motor interlock. We create a new routine named motor interlock. With ladder diagram and non-assignment. Firstly, about a secure interlock, I put mandatory condition. The XIC emergency stop on. Lead to OTE pump 0412 dock secure interlock. If we have any more condition, we can put here around here. Second, about a process interlock, I put one condition. I put one condition here. PIT 1102. PIT 1102 underscore BV. Greater than 5 bar. So I will greater than 5 bar. and lead to OTE bomb 0412 dock process interlock. Okay, that's all for motor interlock. Now we create the main routine in the program and call this routine to run. Right click on motor control and insert a new routine. We name it a main routine. And assignment, we select main. Open main routine and insert a run to use the GSR jump to subroutine instruction to call the subroutine. We jump to 3 routines: motor input, motor output, and motor interlock. Next, we create a new run and use the for instruction. The routine name we input motor direct. For index, that's the running number. Is index of motor we are alias when we create the tag. For example, I already create the tag bump 0412 with alias to motor direct number 1, so index here is 1. But in this for instruction, we need to create a tag for index. I will assign the tag is motor index, motor direct index, with the data type din. For initial value, just let 0. For terminal value, that's the value at which to stop executing the routine. We create a tag name, motor direct terminal value, with the data type din for it. For step size, we put 1. Okay, that's done for instruction. Now in the motor direct routine, we need more to run to link with this for instruction. We open the motor direct routine. First run at the top of routine. With a COP copy file instruction. In this COP, the switch in the motor direct. Index motor direct index. The dash is motor direct. And length is 1. Second run at the bottom of routine. Also with the COP instruction. In this COP, is opposite with a port of COP. The switch is motor direct. The dash is motor direct. With the motor direct index. And the length is 1. Okay, that's done for motor direct routine. Now I come to the phone timer. We put the preset time is 5000. It means 5000 milliseconds or 5 seconds. And one more time, for specific this motor, if PLC requests this motor to open, if the actual motor on site don't run within 5 seconds, the bit of fault alarm will be triggered. That's meaning of fault timer. Okay, now we come to the two program to control this motor. In this application, this motor bump 0412 will run if the level of the tank L1201 underscore PV is achieved 80% and stop when that level is under 20%. I create a level with the name L1201 underscore PV. In the controller name, this is the process value. We create a routine with name bomb 0412 tie ladder diagram. You can program for it in another program. Open it. Okay, now I will create a basic program for control this motor. Normally, to control the level of the tank via a pump, we will use the PID, but in this video, we focus on the motor only. So, for PID, I will create another video for it. We add a new run, insert a greater instruction, GRT. So A, we put L1201 PV. So B, we put 80. This GRT lead to an OTL with text bomb 04 doc pro command. We add a new run, insert a LES instruction. So we put level should be we put 20, and this lead to an OTU with tag pump u pump 0412 pro command. Okay, that's all for motor direct programming. Hope you can do by yourself. See you in the next video.